Hello and welcome to What's That with Prisma Cloud. In every episode of What's That, we'll break down complex cloud security topics into easy to understand concepts. I'm Steve from Bridgecrew by Prisma Cloud, and in this episode, we'll be talking about infrastructure as code, also known as IaC. Bridgecrew is a developer-first cloud security platform designed to change the way teams secure their cloud infrastructure. This all-in-one tool uses automation to find and fix cloud misconfiguration. As a member of the Bridgecrew team, I spend a lot of time working with organizations that are trying to tackle the challenges of securing their cloud. The best way to secure full control of your cloud configuration? You guessed it, infrastructure as code. Today we'll be taking a closer look at all things IaC for a better understanding of what it means, why it exists, and how your team can adopt and maintain it for efficient cloud management. Infrastructure as code, or IaC, allows us to design, build, deploy, and manage cloud infrastructure in code, rather than clicking through a cloud provider's UI or having a long list of CLI commands. IaC simplifies the process of configuring a resource by defining the end state of what you want to be created. From there, your framework or orchestrator, such as Terraform, CloudFormation, Azure Resource Manager, or Kubernetes, will provision these resources properly. This method of building out cloud infrastructure is more scalable than running ad hoc commands, as all of the configurations are stored centrally and version controlled. Want to add a new region for disaster recovery? Just run the same templates in a new region. Working with a large team on the same templates, version control systems, or VCS, allow collaboration using code comments on the code itself. Want to roll back a breaking change you made? Undo the changes in the code and rerun apply, or if you are following GitOps, just run git revert. IaC also provides an opportunity to catch misconfigurations before they are ever a public-facing problem. For example, you can prevent provisioning a storage bucket without encryption rather than waiting for a runtime alert when that bucket is already exposed. In addition, IaC security tools often include more security defaults and best practices and are kept up to date with the latest industry threat intelligence. Let's take a quick look at the history of infrastructure as code. In the beginning, there were many forms of infrastructure as code, everything from mainframes to the autoexec bat system file, which would run a series of must-have initializations for your PC as soon as it was started up. For decades, data center technologists responsible for the setup and teardown of vast numbers of computer systems would automate repetitive tasks, usually using the operating system's shell language. It is called a shell language because it combines a sequence of commands that would otherwise have to be typed into the keyboard one at a time into a single script. These early IaC languages, such as the Linux operating system shell script and later the first generation of Python programming, were designed primarily for the provisioning of remote systems or virtual machines based on a client-server model, and are still very much used today. Some even have the ability to maintain what was being provisioned so that once it was created, it would stay created. These are considered to be imperative languages, which means they are essentially an ordered logical list of commands. Think of it in the context of a recipe for baking a cake. Let's say this recipe walks through a variety of steps, asking you to add a certain amount of flour or add a half dozen eggs whipped to a mild froth. And then at the very end of the list, you are instructed to bake for 20 minutes or until a skewer is inserted into the center and comes out clean. What does that mean? Until a skewer is inserted into the center and comes out clean. What does clean look like? I'm not a baker. That's just confusing. Perhaps maybe that is a bit of a pastiche on badly written imperative IaC. But it's definitely true that IaC written this way does require the reader to understand the end result in advance, as well as the instructions and methods being commanded in order to work properly. Imagine if the title of this recipe just went away. Now, you just have a list of directions with no context. What am I making? What is the result meant to be? Why am I stabbing it repeatedly with a skewer? Now back to our history lesson for a moment. Imperative languages still very much have their place, but when cloud infrastructure started to dominate local data centers, the game changed completely. virtual servers were being provisioned against virtual storage with virtual private networks, and for the most part, non-existent security. Suddenly, IT professionals were faced with the task of keeping track of hundreds of API options for their brand new cloud services, making sure they were always up to date and using all of the new ever-changing features that cloud provider released. Most cloud providers provide access to an API, or application programming interface. This presents a programmatic option using an imperative language. Eureka! We could write our own repeatable code and we can do it in COBOL. Or not. This presented a new challenge. How do we know what we did was done right or securely? Did we add encryption to our storage? And did we leave it accessible to the public? What is the default if I wasn't specific? Over the years, cloud providers like AWS expanded from simple compute and storage to over 200 services. And the API options started to get a bit unruly. This is where declarative languages come into play. Declarative is what we mean today when we start talking about infrastructure as code. In fact, those earlier languages are starting to be referred to as infrastructure as software in order to distinguish them from their declarative counterparts. Remember our cake recipe from earlier? We saw the imperative version, which was essentially a list of directions. Let's take a look at what it might look like in a declarative language. This version simply specifies a resource of type cake. From there, it clearly states the details of the cake in a list of parameters. Above, we can see we're listing a provider, which is AWS. This is the baker we've hired to bake a cake in our hypothetical kitchen. That process feels much easier. The baker, or provider, knows all of the details and instructions of the recipe, or API calls, so we don't have to worry about it. Notice how the declarative language is defining not just a list of what is desired, but a required state. If the state is already satisfied, then there is nothing for the provider to do. This is called idempotency. That means it doesn't matter how many times you apply the code, the result will be the same. Not only is it easier for you to state what you want, but it's easier for you to maintain what you state. There is an added bonus to the declarative model, and that is security. Some of the earlier imperative script languages were referred to as Turing complete. That meant that logic constructs were present to ensure that any and all logical outcomes were possible. It is an essential part of a programming language. Conditional statements and loops also mean that the result is often non-deterministic, meaning that you won't always get the same result for every execution. For IaC, non-determinism is actually a problem, not a solution, primarily because you are unable to compare the results with the code. When the result does not match the code, this is called drift. And if drift cannot be easily determined, then we cannot tell if any runtime issues are the product of poor design or the product of malicious intent. Scripted imperative languages with non-deterministic results are very difficult to secure. SAST, or static analysis security testing tools for languages like this are complex. In this case, it would require a highly intelligent tool analyzing our IaC or IIS code to understand the semantics of the language, the cloud provider in detail, and the potential of every possible outcome. On the other hand, declarative IaC brings with it a huge security advantage. In this case, IaC languages like HashiCorp's Terraform are much simpler to check. Take Checkov, for example, an open source IaC scanning tool with over 1,000 rules for best practices and security built right in. Because the outcome of a declarative language is known, we can rely on it being an accurate representation of the resources that will be created and their relationships to each other. To check for security and best practices, we can apply rules via a simple logic engine to check it anywhere from the desktop where it's created through IDE integrations to simple pipeline integrations to even built-in runtime hooks to create pre-flight checks. This is really important because the IaC code for an unencrypted simple storage can, and probably will, be reused and deployed at scale. One tiny piece of code could theoretically be used to provision thousands or even millions of instances of vulnerable data storage. Remember how I said that declarative languages are defining not just a list of what is desired, but a required state for each item? That means they also enable us to monitor a code-to-cloud consistency to ensure drift is no longer a problem, using our source code control as the reference or single source of truth for what should be, something known as GitOps. Let's recap what you've learned in this episode of What's That? Infrastructure as Code, or IaC, allows us to design, build, deploy, and manage cloud infrastructure in code, simplifying the process of configuring resources. All infrastructure as code is great because it is a repeatable process as code which can provision resources for infrastructure at scale. There are several different languages that can be used to make this happen, the two primary types being imperative and declarative. Imperative languages were the first form of IaC, but the development of cloud infrastructure presents some risks. Declarative languages are much more secure, as outcomes can be determined ahead of time to prevent drift. Hopefully, this gives you a better understanding of infrastructure as code, the vital role it plays, and how best to keep it secure. Visit the Prisma Cloud and Bridgecrew blogs for a deeper dive into the solutions and best practices for infrastructure as code. And be sure to subscribe to our channel and turn on notifications to get more cloud security and technology breakdowns in our other What's That video. Let us know in the comments what topics you'd like to learn about next. I'm Steve, and this is What's That with Prisma Cloud. Till next time.